Students, in this video I will go through two examples of how to perform synthetic division. So in the last video I went through explaining some of the rules for synthetic division. I'm not going to go through the rules for synthetic division, not directly, however I am going to be applying them in this video. So let's take a look, okay? Alright, so this is our divisor here. This is what we're dividing into, right? We're dividing this into this large polynomial here. Alright, so let's see what we can do. So to perform synthetic division, this is a shorthand of doing long division. What I do is I place the 2 on the outside, and then I list out all the coefficients inside, right? So this is going to be 1, -2, then 0, because there's no b to the third, right? And there's also no b squared. So 0, and then 6, and then -17. And what I do with this is I will perform synthetic division by taking that leading coefficient there. I'm going to bring that down. Then I do 2 times 1, which is 2. I add, I get 0. 0 times 0 is 0. I get 0. 0 times 0 is 0. I get 0. 0 times 2 is again 0. And then 6 times, and then I add and I get 6. And then finally 6 times 2 is 12. And then I add again, I get -5. So this last number here is our remainder. And then the stuff in the middle there, okay, that is our coefficient. Now, how does this work, though? I have b to the 5th, right? And I'm dividing b to the 5th divided by b. What I will end up with is an expression that is going to be 1 degree under. So this will turn into b to the 4th, right? And then this is the placeholder for b to the 3rd. This is the placeholder for b to the 2nd, b to the 1st, b to the 0th, or in other words, just the constant, right? So it's going to be b to the 4th plus 6 plus -5 over b minus 2. All right, so moving on, let's try another example. All right, so I have this now, and now if you notice, I have this leading coefficient there. So what we're going to do, okay, is we need to, we cannot use synthetic division if there's a leading coefficient here that's something other than 1. So we have to manipulate this. This is the same thing as 6r to the 3rd plus 28r squared plus 46r plus 42, all divided by 2r plus 2, right? Well, 2r plus 6, I mean. So what I do with this, okay, this is the same thing as 2 times r plus 3. So now this is, so what we do is, okay, we can, if you notice, just keep in mind this is all still a division problem, right? Can we divide 2 into every single term here? Absolutely. Okay. Do I have to do it? Do I have to divide 2 in when I see that there's a common factor here? You should. So this becomes 3r cubed plus 14r squared plus 23r plus 21, all divided by r plus 3. Now I can perform synthetic division. Okay, so what I would do, okay, is I notice now the divisor there is r plus 3, so what goes on the outside will be -3. And then I list out all the coefficients. So I have 3, 14, 23, and 21. I do not need to list out any, I do not need to place in any placeholders because there is a coefficient for every single term. Okay, so what I then end up with is I'm going to add. So this becomes 3 Negative 3 times 3 is 9. Negative 9. 14 plus negative 9 is 5. Negative 3 times 5 is negative 15. 23 plus negative 15, that is positive 8. Negative 3 times 8 is negative 24. Add, you get negative 3. So what does this turn into? This is the same thing as 3r squared, because remember the dividend there was to the third power. So if I'm dividing something to the third power by something to the first power, I will end up with r squared here. All right, so I end up with 3r squared plus 5r plus 8 plus negative 3 over r plus 3. And that is the solution. So let's say if in the event that the coefficient that you had factored out in the beginning was not divisible into all the terms in the numerator, what would happen then? Well, if that's the case, you could have also done the problem in this manner, right? We could have still solved the problem as is, okay? But the expression could have been rewritten in this form. Could have been rewritten in this form, right? And instead, I could have divided r plus 3 directly into that expression, and we'll end up in the same place. I'm just going to quickly go through showing you that it ends up being the same thing, right? So we could have done something like this. And I promise you we'll end up in the same place. We add 6. Negative 3 times 6 is negative 18. Add 28 and negative 18 together, we get positive 10. Negative 3 times 10 is negative 30. Add 46 and negative 30, we get 16. Multiply 16 and negative 3, we get negative 48. Add negative 48 with 42, we get negative 6. So our result, okay, will end up being, what is this? Remember, this is the original problem was this guy here, right? If that's the case, okay, then this is still equivalent to 1/2 of 6r squared plus 10r plus 16 plus negative 6 over r plus 3. Can you guys see that this final answer here is actually equivalent to this, right? It's just with the 1/2 distributed all through, right? So we end up in the same place. So why did I go through this twice with you? Well, that's because I'm saying hypothetically, right? Let's say if the 2, okay, if the 2 over here did not divide evenly into that numerator, right? That's what you would have had to do, okay? All right.